Hi everyone, this lesson is about how we solve a problem like the one here using differential equations. So let's read the question and see what we can find. We have 5,000 litres of water in a rainwater tank treated with 50 grams of a chemical to kill bacteria. The house consumes 500 litres a day and the summertime rain adds 1,000 litres each day. The rainwater mixes completely, so the chemical will be diluted as more rainwater accumulates in the tank. We will assume the tank is large enough to hold all the additional water, it doesn't overflow, and that the rainwater obviously is being used, so some of the chemical will go out with the rainwater each day. Find the amount left after 10 days. So before we try jumping into calculus and writing a differential equation, with a complicated question like this, let's go non-calculus for a minute. So let's set up a little table here. Time measured in days, starting at 0, then 1, then 2, and so on. The next thing would be the mass of the chemical in grams, which is in the tank. Now we know at the beginning 50 grams was added. Let's think for a minute about the percentage reduction. So on the first day, and I'm going to be using a whole time step of 1 day. So this is not calculus, this is, average rate. I would have 500 litres removed out of 5,000. This is a reduction, so it's a negative number, and that would be about a 10% reduction. Now, how much mass would be lost per day? Maybe I should have written mass in front of that. The mass per day, the change per day. Well, a 10% of 50, that's minus 5 grams per day. On the next day, we would have 45 grams. Now on the next day, the family uses 500 litres, but the tank is no longer 5,000. The tank had an extra 1,000 added to it, so effectively the tank is up to 5,500 litres. And that, if you calculate, is about 9.1% loss. And 9.1% of 45, this means we've lost about 4.1 grams of the chemical on the second day. Let's do this one more time. 45 minus this would be 40.9 grams in the tank on the start of the second day, or 2 days after we began. So the family uses 500 litres per day, but because of the additional rain, the tank is now holding 6,000 litres. And that works out to be about an 8.3% loss, or a reduction in real terms of about minus 3.4 grams. So that's enough. We can sort of, extrapolate these. Now this is not going to give us accurate answers, because these numbers that we're dealing with here, these are average changes, the amount of mass over the amount of time, where the time was a whole day. But to solve this accurately, we need to use calculus. So we recognise that the numbers in this column are actually dm/dt, the instantaneous rate of change. The numbers over here in this first column, they're time. The numbers in this column, let's call them mass. And this percentage reduction column, well, that's a little bit harder, isn't it? It's a ratio. The ratio always had the number negative 500 on the top of it. But what about the number at the bottom? The number at the bottom was 5,000, then it was 5,500. So this number here changes. And this number, well, because I have dm/dt, I need to work t into my formula. Let's see how that denominator value is changing in relation to time. These are always jumping up by 500. So that's like an arithmetic sequence. with a first term of 5,000 and a common difference of 500, we would multiply the 500 by the t. If t equals 0, that comes to a 5,000 denominator. If t equals 1, it's 5,500, and so on. Now, how did we actually calculate? What were we doing to calculate? We were multiplying the mass by that ratio, and this is a differential equation that captures the process that we were working on. Now, if you would like to, and I think, I should just comment, I think that going from the word question to that differential equation is quite difficult. That is, I think, the hardest part of solving this question. How did I do it? Well, I certainly would not have been able to write that down off the top of my head from reading the words. So take a step-by-step approach for a few turns to stop and think about the processes that you are using in order to help your thinking. Now, if you'd like to go ahead and try solving that one for yourself, pause the video now and then check back in a few minutes. Okay, well, let's see how we would go about solving this. So I have dm dt, I'll just rewrite this in the usual way, equals, well, I had mass multiplied by negative 500 over 5,000 plus 500t. Let's separate the variables. dm over m would equal negative 500 over, well, do I really need to have all those 500s there? I'm just asking myself this question. If I divided every term in this ratio by 500, I would end up with negative 1 over 10 plus t. Wouldn't that be a little bit more easy to work with? And of course I'd still have to transpose my dt, wouldn't I? It's a lot easier than all those 500s. Now, we would integrate both sides of this equation. Integral of 1 over m is the natural logarithm of m. The integral of 1 over 10 plus t, that is, well, it's a negative sign at the front. It's the ln of 10 plus t. Now, the derivative of 10 plus t is 1, so effectively dividing by 1 doesn't change anything. And we would, of course, add a constant of integration, wouldn't we? Now, what do you think we should do here? Well, there's any number of ways that we could go about rearranging this to find m. But I might do this. I might go negative ln 10 plus t. And I think I might write this as the ln of e to the power c, because that's really just plus c after all. Now, it might be simpler if I go let some new constant k equal e to the power of c. So this is just really ln of a number k. The natural log of m then equals, well, this is the difference between two logarithms. Oh dear, I was going to write log instead of ln. This would be k over 10 plus t. Now, if I have natural log of m on the left equals natural log of all that stuff on the right, I could apply an exponent to both. Or I could simply go, you know what, it must be true that the m thing equals the k over the 10 plus t thing. The argument of the two logarithm functions must be the same. This is pretty close to our answer. We did note, remember, that when time was 0, m was 50. So let's substitute those. When m equaled 50, that's k over 10 plus 0. Gee, that's an easy one. K then would be 500. So, finally, my formula is m equals 500 over 10 plus T. That's the solution to my differential equation, to predict the mass of chemical remaining in the tank at any moment in time after the point where T equals 0 and mass was 50. That was a lovely question. Oh, sorry, we didn't quite finish. We were supposed to calculate mass when T equaled 10, weren't we? I think that's going to be a pretty easy one. 500, 10 plus 10 is 20. I reckon that is 25 grams. So, what a lovely question. Let me reiterate. The most difficult part of the question was going from what was written, oh, whoopsie, I was trying to do green highlight then, what was written here to what we managed to find and write in the form of a differential equation. It is difficult to do these word questions, so my advice is to do like I did. Don't use calculus to start with. Think one day at a time, or whatever time increment is being used. Calculate a few like this, set them out in a table, and then stop and think and ask yourself, what are the mathematical steps I am taking to produce the different numbers in the table? Okay, thanks for watching. Good luck with these sorts of questions when you try them on your own.